An insurance policy will reimburse only one claim per year. For a random policyholder, there's a 20% probability of no loss in the next year, in which case the claim amount is zero. If a loss occurs, the claim amount is normal with mean 1000, standard deviation 400. Calculate the median claim amount in the next year for a random policyholder. So we know that median claim amount is the claim amount at which the cumulative probability is 0.5. So if x is the claim amount and m is the median, then probability x less than equal to the median is equal to 0.5. Now probability x less than equal to m is equal to probability x is equal to 0 plus probability x less than greater than 0 less than equal to m. So x is the claim amount, which of course cannot be negative. So maybe we can do one more step here, because less than equal to m practically means greater than equal to 0 and less than equal to m. So let's also put greater than equal to 0 here. Okay. And that now can be broken into equal to 0 and greater than 0 and less than equal to m. So probability that it's equal to 0 is 0.2, because that's the probability that no loss occurs, plus probability between 0 and less than equal to m. So that gives probability x greater than 0 and less than equal to m is 0.3. Now, only 0.2 of the probability has accumulated up to a claim of 0 by the given condition, the 20% chance that the claim is 0. Therefore, the median, since for median the cumulative probability should be 0.5, so the median will occur in the region where the claim amount is greater than 0. And therefore we need this probability that x is less than equal to m given the claim amount is greater than equal to 0. And this probability is equal to probability x less than equal to m and x greater than 0 divided by probability x greater than 0. And that's equal to probability, when you combine these two, you get x greater than 0 and less than equal to m. And greater than 0 is the complement of less than equal to 0. And this one we just found above is 0.3. And the denominator would be 1 minus 0.8, because less than equal to 0 means equal to 0 in this case, since we can't have negative. We can only have equal to 0, which is 0.2. And so this is 0.375. And therefore what we need is, we are looking at the cumulative probability of 0.375 in the normal table. So the normal table has only cumulative probabilities of 0.5 or more, and therefore we'll look at the complement of this and then use symmetry. So the complement of 0.375 is 0.625. Now if we look in the table, we don't quite find 0.625. We find 0.6217 and 0.6255. So 6217 corresponds to z equals 0.31. And 6255 corresponds to z equals 0.32. So by interpolation, we are looking for 0.625. Remember, we always take the one that we are looking for, subtract the lower one, and in the denominator, we subtract the highest from the lowest. So 0.625 minus 0.621. minus 0.6217, that's the lower one for 0.31, and then in the bottom we do 0.6255 minus 0.6217, and that's 0.9. So that means z is equal to 0.319. That gives us a third decimal place here. Corresponds to 0.625. We're looking for 0.375. So by symmetry of the normal distribution, z equals negative 0.319 corresponds to 0.375. And now in this formula for z-score, when z is negative 0.319, we get the median. And so median is so x will be replaced with median, z with negative 0.319, and the mean and the standard deviation are given to be 1,000 and 400 in the question. 1,000 and 400. And when we do the algebra here, we get m to be 873. That is choice C.